let me run some technologies by you. Your cell phone camera lens that you used to snap that sunset picture last night. The electron microscope that first imaged the COVID-19 virus. How about the microchip that's powering a low Earth orbit satellite miles above your head, feeding data back down to your wireless devices? What do all these technologies have in common? Well, they're all dependent on an array of delicate circuitry, components, and technical operations that need to be designed and sometimes even operated under the most precise of conditions. And as the world's technologies have become more and more precise and more powerful, they've gotten smaller and smaller and smaller. And when you're trying to ensure nanometers of precision, the smallest vibration or blow of the wind or even the shift in a building can be catastrophic. So our worlds of technologies need solutions that ensure the production, the quality control, and the use of these important tools is as robust and precise as the measurements and functions that they perform. I'm Daniel Litwin, the voice of B2B, and on this episode of Made in America, we're driving 30 minutes northeast of Boston to Peabody, Massachusetts, to shine a light on TMC, a leading solutions provider and manufacturer of vibration and isolation control tables. Their team is going to help paint the bigger picture of change that's shaping the scale of consumer and enterprise electronics, and how they're setting a standard for quality in the smallest of technologies. Mr. Steve.
Dan, welcome.
Hey,
welcome
thank
to TMC.
you. Yeah, thank you so much for hosting us here. I really appreciate you taking some time, walk us through everything. It's a little cold though, so I'm
sorry about that. Welcome to the Northeast.
Hey, well, before we actually get into sitting down, learning more about you and the company, I want to touch base on the geographical footprint a little bit. I noticed driving up, there were a lot of industrial parks. Has TMC tapped into that?
Yeah, absolutely. Well, we're in Peabody here, just north of Boston on Route 128. So we're right on the Boston Technology Beltway.
Right.
And a tremendous number of customers in the high-tech industry, nanotechnology applications here. So yeah, we're right in the heart of things here in the Route 128.
Well, Steve, I'm excited to dig in a little deeper then, learn how TMC is supporting all of this great technology in the area, but I know worldwide as well, y'all's footprint is a big one. So let's get that tour. Let's learn a little more.
Great, come on in.
I'm excited. So I'm curious if there's anything about this trend of a technological explosion at the smallest level of production across various industries. Is there anything about this trend that's unique to manufacturing in the United States specifically?
Yeah, well, semiconductor manufacturing is done in many regions of the world, especially in places like Taiwan and Korea. But what's really unique about the US is the high concentration of businesses that design and manufacture what you might call an ultra-precision instrument. You know, extremely, the kind of very, very sensitive instruments that we're talking about. And it's not just semiconductor, right? We also see the instruments that are used in just a wide variety of advanced applications in, again, some of those same industries: photonics, life science, materials research. And there are, many applications at universities, right? So we'll see this from all over the world. But especially in the US, we see a tremendous amount of funding of basic research going to the universities through the funding arms of the federal government and other sources.
Basically, I'm curious if because there is such a significant footprint in the US of both semiconductor manufacturing as well as research, is there a need for them to specifically seek out partners in the US?
Well, we certainly support customers all over the world. But in the US, it really is an advantage, and we do see it being in the same time zones, speaking the same language, easily able to get out and visit with customers and have our technical teams work together. So yeah, there is that advantage.
So then what would you say makes TMC unique in its processes?
Well, I would say what's really unique about TMC, and really our core focus, is that we have these dual core competencies. On the one hand, we consider ourselves unparalleled in our expertise in low amplitude, low frequency, building floor vibration, and its adverse impact on nanoscale manufacturing, experiments, inspection. At the same time, we're fully committed and passionate to being a vertically integrated manufacturer so that we can design the solutions that we make here, so that we can control the quality. And that passion about manufacturing, commitment to manufacturing, those dovetails together perfectly for us, which allow us to do things that we don't see anybody else having the capability of doing.
All right, Steve, I really appreciate you giving us all this background information, helping us better understand TMC's ethos in their work. What I want to do now is try to get a little closer to where the magic's made, so why don't we go check out the manufacturing floor?
Great, Dan, thank you.
Let's do it.
Okay.
We're getting closer to the magic. Yeah. I love it. Well, while we're in here, before we get into the nuts and bolts of the production process, we've got a clean bench here, actually, that's already done. So I'm curious if you could walk me through what we're looking at here. I mean, I know when I press down on this, we get some air pressure, you get some responsiveness. So walk us through like when this is used for and the mechanics of what makes this possible.
So this is one of our Micro-G passive vibration isolation tables.
Okay.
It uses the principle, again, of a mass on a damp spring. The spring is compressed air. So what we've got here is a tabletop where a customer would put their instrument, maybe an optical microscope. It could be an analytical balance. It could be something like a scanning probe microscope, anything that's very, very sensitive to floor vibration. They would put it on the isolated surface here, which is supported by self-leveling air springs that have height control sensor, so it automatically levels. You connect it to a cylinder of nitrogen or an air compressor, and the table will float and keep the payload isolated from floor vibration and level.
Now, in practice, how does that make your client's job easier?
The problem is this vibration artifact comes up everywhere.
Yeah.
Right. So what this is a proven professional solution. The alternative would be to do things like hang bungee cords from the ceiling, or do all sorts of exotic homemade solutions like that, with are fraught with constant needs for adjustment and fiddling around. So what we do is set and forget system to allow our customers to just forget about floor vibration and concentrate on their work.
Love that. Although bungee cords from the ceiling sound like it'd be fun to see.
Yeah.
Let's get that one to run too. No, this is great. Well, Steve, thank you so much for the quick demo. It's really been a pleasure, man.
Great, thanks.
We'll chat soon.
Okay.
The only way to achieve technology tolerances down to sub-nanometers of precision is to isolate the factors that would jeopardize that precision. A light breeze or a train going by a mile away, the natural sway of a massive research building, or the chugging of fabrication equipment, even the slamming of a door. These challenges impact electron microscopy, consumer electronics production, and everything in between that relies on the bleeding edge of powerful nanometer components, where their team is hard at work designing specialized vibration isolation equipment. Mike!
Hey Daniel,
man.
great to see you.
Great to see you too. Thank you so much for your time today, and I'm looking forward to finally getting into the nuts and bolts of making TMC's solutions and understanding all of the quality that goes into your processes. So I think we're at step one right here. Why don't you walk us through where we're at, what we're looking at, and how this feeds into the main process.
Sure thing, Daniel. Yeah, here we are in the TMC factory. We've got about 90,000 square feet here of manufacturing space, just north of Boston on Route 128. And this is one of our loading docks. And what makes TMC a really unique place is we're a fully integrated factory.
Right.
Meaning a lot of what comes in is sheet steel, plate steel, raw materials. We do a lot of fabrication, a lot of conversion, laser cutting, welding, basically everything to build our own product and to send it out the door. The only thing we don't do here is paint.
Right.
So I'm going to take you around the factory and show you what we do with all this steel.
Yeah.
We use about 1 million pounds of steel a year.
Wow.
And we're very, very discerning on the steel that we bring in. It's got to have excellent cleanliness. It's got to have specific surface finish. Flatness is very important to us. So there's a lot of things about the steel that we use that we look at that's also very important that makes our products perform as well as they do.
So how is it that you source that metal in the first place? Do you have specific partners that have already proven to you they can meet the specs you need?
You know, some of the steel that we make only comes from one supplier in the world. There's only one place in the world that can make the steel that we need.
That sounds tough.
So some steel is rather mild and can be pretty crude, but some steel is also very, very specific. So we do all sorts of things with it, and you can take a look at some of the different shapes and sizes of the things.
Can I grab one of these?
Yes, you can. So that's just an example of a small component, like I was saying before. It's just one piece that would go into maybe a larger assembly.
Right.
And this is some 1/2-inch thick steel that was cut on one of our operators here using one of our operations called a water jet. So this is a water jet cutter. What this does is it shoots extremely high pressure water, and the speed and pressure of that water is actually able to cut the steel in these shapes. So we can make very, very intricate shapes and sizes and anything to really do what we need it to do and to become a component in a larger assembly.
So, you know, I've noticed a lot of people on the shop floor today. I mean, you've got a pretty robust team. How many people y'all employ here?
There's about 100 people total at TMC's factory.
Very cool.
And I'd say working out here on the floor right now is probably about 50 people.
Love that. And you know, I see people obviously doing a lot of the work by hand, but then we also have a lot of people manning robotics and sort of assisted equipment. Talk to me about that relationship, about how you know, workers utilize their tools and how they're elevated by some of the investments y'all have made in good gear.
A lot of what we have here is unique because it's a high capital investment.
Yeah.
So we're a real working, fully integrated factory. And especially for an area sort of north of Boston where land's pretty tight, labor's pretty expensive, you know, to have a factory where people come in and do like real raw material conversion and real building is pretty rare around here.
Love it. Great stuff.
Yeah.
All right, let's check out that next step.
This is a part of our machine shop. We have lots of drills and drill presses. Over here is a bender. We're doing some spot welding on some components on this sheet here. We also have CNC. We also have CNC machinery and CNC lathes over here. So really it's all designed for taking that sheet steel and turning it into what we want it to be.
So what are some of the things that the sheet metal is becoming here?
It's becoming primarily vibration isolation systems like tabletops. This, for example, is a sheet for a tabletop.
Okay.
And this would be used if somebody were to get a microscope, for example. If I was a researcher and I had a microscope and I was going to pull my table up to pull my chair up to a table and look through this microscope, well, if somebody walks by and that's going to shake my image, and the floor is shaking, that's going to shake my image. So our equipment is going to absorb or detect and cancel out that vibration to keep your image still. And these are that would be, for example, a surface on which that microscope would sit.
Very cool.
And we'll see a full assembly of that as we get back into the assembly area. These are our lasers. We have a couple different lasers that basically laser out all sorts of different things, from very, very large sheets, very, very large format sheets, to many, many small little components. And what's so interesting about lasering and fabbing and welding is that you take this piece of sheet steel and say it's got some holes in it or something like that. You put a couple holes, they got to be in the right space, so when you bend that sheet of steel, those holes are then in the right spot.
Right.
So the accuracy and the precision of where you laser the different parts and different shapes is very, very important.
All right, so what area are we in now, Mike?
Now we're starting to get into an area which we call bonding and finishing.
Okay.
This is where a lot of our larger structures start to come together. Our tabletops and our platform tops. A lot of what comes in here has already gone through some of the bending and lasering steps and even some of the welding steps, and it comes here to start to be assembled and bonded and put together.
Gotcha.
And it starts to become really pretty big. If you look up, you'll start to see our biggest cranes in the factory.
Oh, yeah.
So above us, we have 5,000 pound capacity cranes.
Ooh, okay.
And you probably noticed there are a few cranes out around.
Yeah.
But you know, the cranes get bigger as you get further down the factory because we start building bigger and bigger stuff towards once everything starts to come together.
You've got really flexible gantries here too. I mean, I'm guessing these are mobile up and down the shop floor?
Yeah, absolutely. They go up and down, they're back and forth on this bay, and we have 1, 2, 3. I think there's another one way down there.
Yeah.
So all of these cranes are an intricate part because one of these optical tables, for example, might weigh several thousand pounds. And here's an example of an optical top that's not quite finished. But you can see all of the different parts of it: the lasers, the welding, different cut pieces of steel.
Right.
Up on top, we have an array of precision tapped holes. So
Right.
every one of these holes is drilled and tapped to this facility. And inside, it's all been pressed together with our proprietary honeycomb core structure. So it's been laid on one of our bonding bricks. It's been pressed down and compressed with epoxy and cured for over 24 hours.
Wow.
To create this monolithic, stiff, very flat, very accurate structure, all from raw sheet steel that's come in. Yeah, so let's move on to the next area. So on your right here, you can see a bunch of weighting jobs. These are stainless steel skins that'll be on the exterior of some of our vibration platforms.
Okay.
And over here is a finished example of a platform that we would build here that would be supported by one of our isolation systems.
Very nice. So how is this used in practice then?
In practice, you would have a large instrument. It might be something that in a semiconductor factory that's processing and checking wafers. It might be an electron microscope. It might be a nuclear magnetic resonance spectrometer. It might be something very, very large, something very, very sensitive. And you're gonna put it on this platform, and then this platform is gonna be supported underneath by one of our isolation systems.
Gotcha.
Which we haven't seen built yet, but we're gonna go talk about those a little bit later.
Very nice. So now we're in the assembly area. I'm seeing a lot of painted and finished, what looks like bases here with all of the air pistons. Can you walk us through what we're looking at here and any of the highlights in the technology?
Sure, so this is one of our most popular products, and there's several here that are going to be assembled pretty soon.
Yeah.
But this is really the culmination of really all the lasering, all the drilling, all the bending, all the welding that we looked at before. Created all these little components that all kind of came together and are being assembled right here where we assemble our passive products. And this is an example of a frame that might be for a lab table. So you might get a tabletop over from the bonding area, and it's gonna sit on these 4 isolators. The customer is gonna put pressurized air into it, and it's gonna cause these isolators to float. You're gonna have a floating piston on air, basically on a cushion of air, floating this tabletop, that then the customer can go and you do whatever they need to do on it. Put a microscope on it, put an optical setup on it, do an experiment on it, anything that's gonna be vibration sensitive.
So when I was chatting with Steve, we were actually at a working clean bench.
Oh, great. You saw the one in the other room?
Mm-hmm. We were pressing down on it, and I love how responsive it is. It's almost got an intuition to it. You push down on it, and it responds in a very appropriate way to level out and control itself as it's filling back up with air. Can you walk me through how that technology operates in a way that feels so intuitive and smart, even though it is still very analog in its machinery?
Well, yeah, that's important. What you're talking about is self-leveling.
Yeah.
And all of our area tables have self-leveling capability. And it's just a matter of valves and control arms. So you can see that there's 1, 2, 3, 4 different air valves on here. As that control arm raises and lowers in response to a moving table, it's going to let in or out more air. And as it does as it moves in one direction, another control arm is going to move in response to that.
Gotcha.
And so what they're all trying to do is try to equalize the pressure amongst all 4 isolators to make sure it stays self-leveled.
It's simple, and yet it's so robust and detailed. Lovely stuff. Well, let's go check out those active isolators then, too. I'm curious about that.
Let's head over to the active area.
All right, so we've got a little bit more assembly to explore. What I find interesting about this area is how you're combining 2 of your different technologies into one solution. Can you walk us through that and what the methodology is to make them both work together in synergy?
Sure. Yeah, I think what we're looking at here is a really great example of all of the different capabilities we have here at TMC kind of coming together.
Cool.
In one of our passive isolation systems with acoustic protection. It's an acoustic enclosure, but also has internal air isolators built into it. And you can see the leveling arms are actually installed on this one already, which one I have. So we have a self-leveling, air-isolated table built inside an acoustic enclosure.
Right.
And what's so interesting about this is that this entire assembly was completely built here. All of these different pieces, these angle pieces, the legs, the framing, all of this came in here as sheet steel. It was welded, bent, drilled, put together, sent out for paint, come back here. Now we're finally doing all this assembly to get the isolation systems and the acoustic foam in there.
Wow. I mean, it's pretty incredible. I think it, again, speaks to just when you bring the whole process in-house, this is the level of quality you can deliver on, and you're able to make small tweaks when you need to. You're able to meet those customized specifications. You just got to have that precision and that ability to control all outside forces. Well, this is a beautiful machine, and I'm excited to see it in practice, hopefully.
Indeed, so are we.
All right, what's next for us, Mike?
Well, we're going to stop and look briefly at our active products assembly area. So we're going to be looking at how we're putting together our most advanced isolation systems.
Very nice. All right, well, let's go check it out. Perfect.
Sounds good.
All right, Mike, so I'm curious to understand how you see TMC setting a standard in your eyes, right? TMC is really putting a lot of focus on helping partners achieve obviously tighter tolerances through vibration isolation, but really it's all about controlling external variables and doing so by building quality into every step of the process. Can you describe those core competencies that you think make this entire quality production process even possible?
You know, TMC, we're a company filled with engineers. Most of the folks that work, you know, in the sales department, obviously in the engineering department, in our marketing department, and not to mention in manufacturing. We've got a lot of people here that just enjoy solving problems, and we've got a very collaborative culture. So that collaborative culture is very, very important, because not only do we work well together, and we work together to come up with innovative solutions, to come up with to handle very complex customer requests, but that collaboration, that collaborative approach extends outside of the walls of TMC, and the customers see that. So when they call TMC, they're going to talk to somebody that is going to work with them to figure out exactly what they need.
And with every decade comes new innovations and new ways for you to find success. So I'm curious what, in your perspective, through your eyes, what you see as the strategy for that success, right? How have you all managed to keep in front of this sea of change to not only stay in business, but thrive?
I think there's two things that make TMC continue to grow and thrive. And one, it's customer support, it's customer focus. We really do strive as best we can to make sure our customers are satisfied.
Sure.
We want to make sure they get the right solution that works well, that's going to last a long time, and is a very, very high quality. So I think we really strive for customer satisfaction. So that's a very important part of our strategy moving forward, is to make sure our customers are satisfied.
The tried and true tools of yesterday are innovated upon and replaced come tomorrow. And every industry is challenging preconceived notions of where technology can be put to use, for what purpose, and at what size. Our consumer devices become more compact, our manufacturing more powerful, and our sciences upgrade their tools to make startling and groundbreaking achievements. And all of this will only keep the foot on the gas for Moore's Law, pushing electronics tolerances smaller and tighter as industry seeks its next big improvement. So with TMC behind the scenes, making sure that critical tech leaves the production floor and runs in the laboratory with supreme quality, the brightest in their fields can know their work has the care and attention it deserves at every level, even the smallest.